All right, for math today, you'll see that there is a picture in your packet. This is like our chart for the week, kind of, because we're going to be learning some new vocab words that you're going to need to know. So factor pair is something that you really need to know. A factor pair is just two numbers multiplied together. So a factor pair for 6 is going to be 2 and 3, because 2 times 3 gives you 6. Or a factor pair for 20 is 4 and 5, because 4 times 5 gives you 20. Or a factor pair for 2 is 1 and 2, because 1 times 2 gives you 2. Okay, so let's look at that on your notes. It says draw arrays to show all the factor pairs for 12 on the grid below. The array for 1 and 12 is shown. So 1 times 12, that's the factor pair that gives us 12. What about, I know that it's kind of erased here, but like the grid isn't looking very good anymore, but 1, 2, 3, 4, 5, 6. So we still have 12 boxes here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, because 2 times 6 gives us 12. So here's one of our factor pairs, 1 and 12. Here's another factor pair, 2 and 6. And there's another one we could do. I'm going to draw it over here where I can see things a little better. 1, 2, 3, and 1, 2, 3, 4. 3 times 4 equals 12. Now, for factor pairs, those are the 3 factor pairs all for 12. You don't need to flip them around and say, oh, well, 12 and 1 are 1 as well, and 6 and 2, and 4 and 3. You don't need to flip them around like that. You can just, each factor pair is the same whether it's flipped around or not. So 1 and 12 is the same factor pair as 12 and 1. So for 12, we have 3 factor pairs. So here it says list all the factor pairs for 12. We have 1 and 12, 2 and 6, 3 and 4. All right, next it asks us to use the table to find all the factor pairs for each number. So for 32, they've already given us one. It's 1 and 32. And it tells us that there's 2 and something that's going to give us a factor pair. 2 and something else. Well, I know I could do 32 divided by 2 to figure out what it is. 1 times 2 is 2, subtract and I get 1, bring down my 2, 6. 6 times 2 is 12. So 2 and 16 are going to give me 32. Now, for my next pair, I could think about the number 3. Would 3 work? Well, I can try to do some division and do 32 divided by 3. But I'm going to find out that this is what I get instead. 10 remainder 2. So that is not going to be a factor pair. 3 and something else are not a factor pair because it can't divide up by 3 evenly. But what about 4? Does 4 times anything give me 32? Oh yeah, it gives me 8. I know that one for sure. That was easy peasy for me at least. What about 5? Well, if you really think about it, if you count by 5s, 5, 10, 15, 20, 25, 30, 35, 40, we're never going to get to 32. What about 6? I know my 6s as well. It goes 6, 12, 18, 24, 30, 36, so that's not going to get me there. What about 7? 7, 14, 28, 35. Nope, that's not going to get me there either. So we found all of our factor pairs actually already for this one. And you know that because we just ended at 7, and if we were to go to 8, we don't need to do 8 because we already have 8 over here. So once you get up to this number, you're done. So what about 44? Well, I have 1 and 44. Let's see if I can do 2. 44 divided by 2. I know 2 times 2 gives me 4. And I know 2 times 2 gives me 4. And that does divide evenly. So 2 times 22 gives me 44. What about 3? Well, I can picture that division problem in my head, and I can actually already tell that that one's not going to work, so we're not going to do that one. What about 4? Ooh, I know 4 and 11 make 44. What about 5? No, that one's not going to work because if I count it by 5s, I would go right past it. What about 6 or 7 or 8? Now, to me, the most challenging thing is you kind of have to check all of them. But I will just tell you right now, there aren't any more for 44. Okay? All right, our next one is 100. 1 and 100 gives us 100. I know that 2 and 50 does. I know that 4 and 25 does. I know that 5 and 20 does. Now, if you didn't know those off the top of your head, that's okay, but you would have to check for all of them. And I know that 10 and 10 does. So here when it says to list all the factor pairs for each number, you have to make sure that you do like 1 and 29. Or for 63, you have to do 1 and 63. Don't forget about those ones because those count. But for 29, there aren't any other factor pairs. For 63, there certainly are because I know right off the top of my head that 7 times 9 gives me 63. But I can't think of any other ones. All right, one other thing we're going to talk about is prime and composite numbers. So let's go back to our little chart. A prime number has only 1 in itself as a factor pair. So, for example, 2, I know that's a prime number because the only factor pair is 1 and 2 for it. I can't multiply anything else together to get to 2. Or for 3, I know that 1 and 3 is the only factor pair. I can't multiply anything else to get to 3. Same with 5, 7, 11, and 13. Whereas for a composite number, it has more than one factor pair. So 4, it can be 1 and 4, and then 2 and 2. Or for 6, it can be 1 and 6, 2 and 3. Or for 12, we already talked about the fact that 12 has a lot. So 29 is actually an example of a prime number because the only factor pair is 1 in itself. You can come in. Whereas a composite number has more than one. So for 63, it has 1 and 63, and it has 7 and 9. So let's look then for 24. One of our factor pairs is 2 and 12. You can see that 2 times 12 is going to give you 24. Or 8 and 3 would give you 24. Or 1 and 24 would give you 24. There's other ones, right? But it's asking, is 24 a prime number or a composite number? And explain your answer. Well, 24 is going to be composite. Because remember on our chart, we said if there's more than one factor pair, it's going to be composite. So here we need to tell whether these numbers are prime or composite. I'll give you a hint. To figure out if it's composite, you just need to be able to come up with at least 2 factor pairs. And then you know right away, 2 or more factor pairs. And then you know right away that it's composite. So, like 99, I know obviously every single one has 1 and 99. But I know 9 and 11. So that one is going to be composite. For 72, I obviously know 1 and 72, but I also know 8 and 9. So that is going to be composite. Whereas 31, I know 1 and 31, and I can think as hard as I can, and I can't think of any other factor pair. So that one is actually going to be prime, because that's the only factor pair for 31. For 45, I can think of 1 and 45, and I can think of 5 and 9. So that's going to be composite. For 19, I can think of 1 and 19, but I can't think of any other one, so that one's going to be prime. Okay? All right, we're going to move on because I think, hopefully you're getting it. If not, go back and watch the video again. This asks, is 2 the only even prime number explain. Remember that even numbers, we talked about this on the spelling list. 2, 4, 6, 8, 10, just continuing to count up by twos. And it's wondering, is 2 the only even prime number? Well, remember, prime means that it has only one factor pair, one in itself. One factor pair. So 2 has the factor pair of 1 and 2. Let's think about, so this one is prime for sure, but it's saying, is it the only even number that's prime? So what about 4? 4 is 1 and 2, and 2 and 2. So that one's composite. Hi, you can come in. Or we have 6, which 6 has 1 and 6, and 2 and 3. So that one's also composite. So I think that, yes, 2 is the only even prime number. Because we could continue to check these. All of those are going to be divisible by 2, so all of those are going to be composite. All right, so your homework is this page right here, page 5. You can, it's basically very similar to your notes. You're finding the factor pairs for each number, so you're going to have to do some checking to be able to find those. You're going to say if these are prime or composite, so you just have to write that in the blanks. And then this one you just have to describe in your own words whether a number is prime or composite. All right, just comment if you have any questions. You've got this.